know that we covered this classwork solutions review in class, live class on the 1st, but I wanted to also put a review video with the solutions so that you could look at it on your own time. And this was the classwork from May 27th on quadratics and creating tables of values to match a quadratic equation or function, and also then to graph those functions, which is going to turn out to be a parabola. We have the equation y equals x squared plus 2x minus 8. First thing to realize is that a is equal to 1, b is equal to 2, and c is equal to negative 8. And that's stemming from the standard form of a quadratic equation, which is ax squared plus bx plus c. The next thing would be to figure out the vertex, and before you do that you need to know what the axis of symmetry would be, which is the x value of the vertex. And we find this by using the formula x equals negative b over 2a. We know that b is 2, so it's going to be negative b, negative 2, over 2 times a, and a is 1, so it's going to be 2 times 1. This is going to turn out to be negative 2 over 2, which is a negative 1. That's your x value of the vertex. And then we have to find the y value of the vertex. And we're going to do that by substituting the x equals negative 1 into the equation. The equation is again y equals x squared plus 2x minus 8. So x squared is now going to be, I'm going to use negative 1 for x, I'm going to square it, plus 2 times x, which is a negative 1, minus 8. This is going to come out to be negative 1 squared is 1, 2 times negative 1 is negative 2, minus 8. 1 minus 2 is negative 1, minus 8 is negative 9. Therefore, our vertex is negative 1 comma negative 9. And we're going to leave 3 of the rows open, and then we're going to put the vertex in the fourth row. And the work that we just did here would go in this middle area here where the computations are asked to be shown. And then we're going to choose our x values very carefully. Negative 1, we want to show 3 x values below that, less than that. So we're going to use negative 2, negative 3, and negative 4. We'd also like to show 3 x values above that, so we're going to use 0, 1, and 2. And we're going to show our computations and then find the corresponding y's for each of those x values. When x is negative 4, our formula is going to be negative 4 squared plus 2 times negative 4 minus 8. When x is negative 3, we're going to be using negative 3 squared plus 2 times negative 3 minus 8. When x is negative 2, our computation is going to be negative 2 squared plus 2 times negative 2 minus 8. We already have the vertex. When x is 0, we're going to use 0 squared plus 2 times 0 minus 8. And then we'll have when x is 1, we have 1 squared plus 2 times 1 minus 8. When x is 2, it's going to be 2 squared plus 2 times 2 minus 8. And we're going to use the order of operations to figure out what those y values would be. However, as presented in the live class, we could have our calculator help us. We can go to y equals, and we can plug in the equation that we're interested in, which is x squared plus 2x minus 8. And then we're going to graph that. And we always want to consider the window. I changed the window for another problem, so I'm going to go ahead and change it for this one. I'd like to show, for my x values, I'd like to show from negative 10 to 10, and I'd like to count the scale by 1 whole. For the y min, I want to use the same idea with the negative 10 as the lowest, or the min y. Our y max says positive 10, and I'd like to count that by 1s also, and then now I can see the graph. Once again, that's under the window feature, which is something that you have to consider. The window is how much of the graph you're seeing. And then I could go to second graph to find the table of values. I want to find x is negative 4. The y value that corresponds is 0. When x is negative 3, the y value that corresponds is a negative 5. When x is negative 2, the y value corresponding is a negative 8. When x is negative 1, y is negative 9. That's your vertex, your turning point. When x is 0, y comes out to be a negative 8. When x is 1, y comes out to be a negative 5. When x is 2, y comes out to be a 0. And after choosing those x values carefully and working out the computations and finding the y values, you should be seeing symmetry. These ends are matching up, these values are matching up, these are matching up, and the one in the middle would be that vertex. Now we can go ahead and graph. First, set up your grid. And now we're going to use our table and plot these points. Negative 4, 0, which is right here. And since it's on the x-axis, it's an x-intercept or a root, so that's one of the solutions. Negative 3, negative 5. Negative 2, negative 8. Negative 1, 9. Negative 9, rather. 0, 8, negative 8. And right there, you have x is 0 and y is negative 8. That's your y-intercept. One, negative 5. 2, 0, another root. X-intercept. Connect these with a smooth parabola and show arrows because it does extend in both directions.